Thanks. Cool. You guys can all hear me. So, my name is Mike, and there's going to be a lot of content on these slides. So, just quick disclaimer: I've tweeted them out. My Twitter account is Mike Arpaia, just my first name, my last name. So, if you want to take notes, you don't have to take notes on anything that's on the slides. So, a quick overview of what I'm going to talk to you guys about today. What I want to talk to you about today. So, there have been a lot of talks about OS Query, what the features of OS Query are, and how it works, and all that good stuff, and I don't want to kind of enumerate the features of OS Query today. I want to take a different perspective on reasoning about host intrusion detection and kind of talk about, let's say you are on the infrastructure security team at an organization. You don't have host intrusion detection at your company, but you'd like to roll it out. What are the kind of steps along that process? What features of OS Query would you take advantage of at those different steps? And what are the steps? Like, what is a good place to get started? How should you progress? Where should you kind of pause for a bit and focus on getting a lot of value out of the intelligence that you can provide and what have you? So that's the kind of objective of the talk here, is to walk you through this path of what it's like to deploy host intrusion detection at an organization. We're going to use OS Query as the example. So I'll explain a little bit more about OS Query in the future, or in a few slides. But first, my host intrusion detection background. I used to work at a company called Etsy in New York, and when I was there, I built and deployed and open sourced a host intrusion detection system. And then I went to Facebook, and I started the OS Query project, and built up a really awesome team around it that still continues to live on really awesomely. And then I was an engineering manager at Facebook, responsible for all intrusion detection infrastructure. So in addition to host, it was network, application, email instrumentation, stuff like that. And now I am the co-founder and CTO of an endpoint company called Collide that uses OS Query, unsurprisingly. So little open source disclaimer. At Collide, we open source a lot of tools that we use to manage OS Query, and I have nothing to sell you today. I'm trying to sell you on using OS Query, not the products that Collide creates. Collide does create a number of open source tools that we use internally to manage OS Query, but we're not trying to sell managing OS Query, so we don't think that those tools compete. So I'm going to talk to you about them, but there are alternatives. We're not the only game in town with open source OS Query management tools. There's a number of really cool alternatives, including Sargent from Okta, which Matt Jane over there wrote, and a number of really cool alternatives that I know some people in this room also use at their organization. So just quick disclaimer. So some initial assumptions that throughout this talk, I'm going to explain the thought process of, starting at rolling out host intrusion detection at an organization, and some quick assumptions of this fake organization is that I'm assuming that this organization has mostly Mac workstations, mostly Mac desktops with a bit of Windows and Linux spattered. I'm assuming that this organization uses all Linux in production, maybe a little bit of bare metal, but mostly in the cloud, say. It doesn't really matter. And also, for the sake of this talk, I'm assuming that you have a strong desire to host your own software. You have no budget, no vendors. You don't want closed source tools. You want to do it yourself. You're interested in running your own infrastructure, and you don't want to pay for anything. And I'm also assuming that you have some existing ability to deploy software and update it in your organization. I think that's a more important problem than host intrusion detection. So I'm assuming you've already solved that if this is the problem that you're focusing on now. And I'm assuming that you have some existing logging and alerting infrastructure at your organization that you have SOC, you have some sort of ability to collect logs and alert on those logs. So those are the assumptions. I hope they're fair. The other, I'm going to recommend a rollout strategy for host intrusion detection in this talk, and my recommendation is to start with your desktop environment when it comes to host intrusion detection, because there is a much higher, in my opinion, there's higher risk in the desktop environment. That's where the majority of modern attacks start, and it's also lower risk to deploy instrumentation software to that environment. So it's a good place to start because you're decreasing your organizational risk while increasing the likelihood that you're actually going to find compromise. So start with your team first. Start with teams that you work with. and then expand throughout the desktop environment, and then extend onto the production environment. So the specific step-by-step that we're going to go through, there's 6 steps. First, I want to talk about like the initial research and development of like, okay, like you need to do this, you need to roll out some host intrusion detection, you want to play with the tool. You want to like see that the logs will be something that you can take into your log aggregation mechanism, and they look good. The insights that you can get out of this tool seem valuable. Like on to the next step. The next step being remote configuration. You need to deploy this tool out to a lot of people. You need to be able to configure it remotely. You need to be able to get logs back remotely. You need to be able to interact with it from some central management point. So we'll discuss kind of some of the options there. And then step 3 is, all right, you've got it to a few teams, you've got like your proof of concept going, you need to reliably and sustainably deploy it to the entire desktop environment. Step 4 is, you've been using it in the desktop environment for a while, now you want to start instrumenting production. What are some things you should be concerned about when you like start moving into production Linux instrumentation? And step 5 being complete production deployment, like 100% of every workstation and server at your organization is instrumented, and you're actively like performing intrusion detections on those endpoints. And then step 6 is if you work at a really big company, like when I used to work at Facebook, you likely should have some sort of mergers and acquisitions instrumentation strategy. Like your company might, you might find out that like next week you're closing a deal with this new company, and they are all FreeBSD hosts or something like, and you need to be able to instrument those operating systems. So like what you should reason about to just like be prepared for the fact that your production environment might not always be as static as it is today. So those are kind of the steps, and that's that. So first step is the initial research and development of, you have this endpoint instrumentation problem, like you've heard OS Query is cool, it has a really awesome website, and you want to explore using it more. So are folks here familiar with OS Query? Has anyone ever heard of OS Query? Cool, so look about half. That's cool. So OS Query, the whole idea of OS Query is basically you write SQL to articulate a fact about an operating system. So it might be like select star from apps would enumerate all the apps, or select star from kernel extensions would enumerate like a variety of information about a kernel extension. And the whole idea is like all of these tables, there's like 130 tables in core at this point. And the whole idea is like you can join them together, you can write interesting SQL queries that like expose a fact about an operating system, and then all of the OS Query tools kind of allow you to take that idea and apply it to different operating system instrumentation objectives. For example, you might have a query that's like select star from kernel extensions, for example, and you might want to know like when that data, how that data changes over time, like how the results of that query change over time. Maybe you just want to get the results every day. Maybe you like are maybe you're trying to instrument USB devices that are getting plugged into workstations, and you like only care about when USB devices get plugged in but not unplugged. Like there are a variety of different ways that you can take the SQL query to an operating system, apply it to your organizational objectives, and get interesting logs that match what you're interested in. So the whole idea is like you write these queries, and there is a declarative configuration that you can give OS Query. So you kind of articulate, here are the queries that I want to run, here are the parameters of like how I want the logs of the results of these queries, and you give that to OS Query, you get logs out. Config in, logs out. Pretty straightforward, right? So OS Query is a declarative JSON configuration, as I said, and both like how you distribute configuration and how you get the logs are very customizable. So for your initial proof of concept, it can be kind of overwhelming because you're like, damn, like I really like want to see if the logs that I can get out of this tool are going to be useful, but I don't want to have to set up all these servers. I don't want to have to go like provision, cloud workloads in order to just see if I like these logs. So my recommendation here is to use the default plugin. So like I said, all of config and logging and like remote interaction, like all of these things that you can do with OS Query are all pluggable, so that you can say, all right, I want to read configs from the file system, or I want to read configs from a TLS endpoint, or I want to read configs from somewhere else, Zookeeper. The default plugins are file systems, so like read the config from the file system, write the logs to the file system. And my recommendation is, as you're getting started, just use the file system and just like verify, like write some queries, use the file system, and see if the results that OSQuery can log for you are useful and if they'll work in your environment. And focus on, finding data that's going to be useful. This is a really naive configuration, and it's basically just so OSQuery allows you to group queries into what we call query packs. And a query pack might be like, IT instrumentation. Maybe, IT wants to know all of the apps that are installed. It might be, deeper operating system security instrumentation that you're performing. Like if it's in production, you might group together all of the queries that do MySQL intrusion detection or something. It's just like an organizational way of grouping together queries. So in this example, I have a pack called desktop monitoring, and I have a query called users that's just select start from users, and I'm running it every 60 seconds. So this is a minimal configuration that'll just enumerate a result set of how the users change over time, and the interval 60 just is like the resolution of the query that you'll get. So if your users don't change on a desktop, you won't get logs, but if they do, you'll probably find out within about 60 seconds. And here's an example log. So it's kind of small, but I think it should be pretty easy to kind of see what you're getting out of here. The top section is like metadata about the host, about the time of the event, any decorations that you've configured. So like in here, in this example, we've configured OSQuery to like additionally log the version of OSQuery that's emitting these results. So those will all be in the decorations stanza. And then you have the columns that were changed and what action happened. So in this specific example, a user Victor was added, and this is basically saying like you have the result set and a row was added to the result set. And in this case, that is indicative of a user being created, but that could be anything based on your specific query. So ideally, you've messed around with OSQuery a little bit. You've written some SQL queries that you think expose cool aspects of your operating system that you're using locally, and you think this is cool. You've gotten value out of the logs, but using the file system in this way is not very useful for if you want to monitor like the person who sits next to you. So the next step that we have to reason about is remote configuration. So, all right, you've got your one endpoint configured and instrumented. Now you want to start configuring and instrumenting more endpoints. So, like I said, with regards to config, distribution, log acquisition, and remote interaction, I'm going to call that live querying, like just executing queries on arbitrary machines. Those are kind of the three ways that you have to interact with OSQuery. So the first one, configuration distribution, you generally have two options. You can either distribute configurations to the file system, or you can run a TLS server that serves the configurations. Now, if you're configuring via the file system, it is, it's easy and it's simple and reliable to just, read files from disk, but it requires that you have some sort of organizational maturity around the ability to distribute configuration, which, may or may not be that realistic in your environment. The other option, TLS or gRPC, like there's being some remote endpoint that you're pulling configuration from. This is great. There's a lot of open source options. You usually get live query and like remote interaction with nodes for free, and that's really cool. But now you're an ops person and you like need to run a server, which, based on your organization may or may not be something that you're super interested in doing. So, keep that in mind. Log acquisition options, so let's say, all right, you figured out how you want to get your OSQuery configuration out to all your endpoints, but now you need to get logs back. How are you going to do that? There are generally like three classes of options. You can either use the file system, so you can write the logs to the file system and then like deploy some additional forwarder to get those logs back to some remote like log aggregation infrastructure, or you can use the TLS or gRPC plugins in OSQuery to send those logs to a remote server and then like process them all on the server, and that's all like buffered locally and reliable so that you don't miss any logs. Or there's also a set of plugins that are very tightly integrated into the AWS ecosystem. Pros and cons of all of those. AWS is cool. Con requires AWS. TLS and gRPC are cool. If you're likely getting this for free, if you're already using a TLS server to manage OS query. And with the file system, it's simple and reliable, but sometimes it's annoying to have to configure a additional log forwarder if you don't already have one of those. So keep that in mind. When it comes to live query, when it comes to like interacting with hosts in a live automated way, TLS and gRPC are pretty much the only game in town. So if that's important to you, then that's kind of limiting your choices. So my advice for you would be to consider using TLS and gRPC. So that's like from here on in, I'm gonna assume like you went through these options and you came to this conclusion. And your conclusion is, all right, we're gonna run a server. And that's, OS query is gonna interact with this server, and that's great. Okay, so the question is, what kind of information about TLS can you get from this approach? When I talk about TLS and gRPC in this context, I'm not necessarily talking about like instrumenting the transport. I'm more talking about like you have OS query running on a bunch of nodes, and you can use OS query to perform like various operating system analytics objectives, and you're using a server that is like exposing either TLS and or gRPC transport so that the OS query nodes can all kind of like connect back to your C2 basically. Can OS query get? If you go to osquery.io/docs, there's like a whole enumeration of all of the aspects of an operating system that you can instrument, but there's like over 100 tables on each platform. So whether you want to know more about the software that's installed on the laptop or on the device, or whether you want to know more about certain operating system configurations, or whether you want to know more about what kind of records are in various persistence mechanisms. Like on macOS, for example, like most macOS, there's not that many ways to persist on macOS. Most macOS malware persists via launchd, which is basically max. It's like PID1 on macOS that launches everything else. So you interact with launchd, you schedule some malware on a Mac. So like, if you want to observe malware that's persisting on macOS, perhaps you instrument launchd and then do some analytics on that data set. So there's a variety of data you can get with OS query. So so the other thing that you get out of TLS and gRPC is a fancy live query UI. Say what? So we have an open source tool at Collide that we use for doing this kind of thing sometimes, and it's pretty easy to set up. I just have a screenshot here of the admin settings where you can configure where emails should go, what the domain name of your server is. Pretty straightforward UI. There's like a little setup wizard as you deploy it. And then that gives you this interface for reasoning about your OS query configuration. So on the left, you have OS query options. So each of these items is kind of a different option. You can configure like how often each node should check into the server. You can configure a whole mess of stuff. We'll talk more about OS query options when we talk about production, because it becomes more important to like tune OS query when you're deploying it to production, but it's not really super important in this context. And then the other thing that you can do via the UI is configure the schedule. You can kind of like compose and articulate queries, group them into packs, mess with the configuration options and the parameters of each query and what have you. There's also a CLI that we're working on. So if you prefer to use like source controlled files and a CLI, like similar to like Kubernetes manifest and kubectl, and you have this workflow for managing source controlled files, that's also coming in Collide Fleet as well. So this is cool. You're like, all right, great. I am on my way to like being able to remotely control a set of OS query nodes, and now I'm interested in desktop deployment. So I want to proliferate OS query and these packages that I've created out to all of my hosts. Whether it's my team, additional teams, all the desktops. That's the objective. So when it comes to enrolling hosts, you have two options generally for distributing OS query across your infrastructure. And you can, so Facebook publishes packages. They sign the binaries, package them, sign the packages, distribute the packages, and you can download them from osquery.io/downloads or from S3, which is where osquery.io/downloads gets them from. And you can distribute out all the binaries. But that's just the binaries. Now it's a daemon, like OS query, in order to run this OS query process, it's like a long running daemonized process. You need some way to on macOS, we just talked about launchd. You need to be able to distribute a launch daemon as well as the configuration that articulates startup options that allows OS query to connect to Fleet. So 2 options. Some people distribute the binaries via like the Facebook distributed packages and then distribute their configuration and the either like systemd unit file and or the launch daemon to start up OS query. They'll like distribute those 2 packages separately. Some people, this is what I personally recommend, will distribute the binaries and the kind of the launch daemons or the systemd unit files to start up OS query together in one kind of atomic package. So if that's what you're interested in, we have an open source tool called Package Builder, which allows you to just kind of articulate some of the different options that you have with packaging and distributing OS queries. So you might, like we host an auto update service for OS query that uses the update framework for content trust. You may or may not want to use that. It's not enabled by default. You might want to pin a certificate pin to like your OS query server so that no one can, stand up a different OS query TLS server on a captive network or something. A variety of options for how you want to create packages. Pretty cool, pretty fun. Hopefully you find it useful if you don't like building packages yourself, which, nobody likes building packages. So when it comes to, all right, so let's assume you have these packages now, you need to distribute them. There's like a variety of open source options for doing this for various operating systems. Some of them are enumerated here. I hope that your organization has this capability. If your organization doesn't have this capability, I think it's more important than host intrusion detection. And that's all I'll say on that. Okay, so now like assuming that you've set up Collide Fleet somewhere in the cloud, you have created these packages that will connect OS query to your OS query TLS server, and you've distributed them, and you have all of your desktop hosts connecting into this server. You should this is where you should pause and go write a ton of queries, go write a ton of alerts, and start getting good at finding bad with OS query. And before you move on to any other environments, you have OS query deployed to 100% of one environment. So you should start writing queries, interacting with the community to find queries that other people have written, deploy the built-in query packs that come with OS query, and try to get good at finding bad with OS query. And this is great because the more you learn about OS query in this low organizational risk context, the more you will be able to kind of add value to the additional environments that you deploy OS query to. So that's great. You're like, okay, awesome. This is really fun. I have now deployed. I'm trying paper notes for the first time, so don't mind me. But okay, so let's assume you've got it out to all. You've got OS query deployed to all of your desktops, and it's going really great. You've written a bunch of queries, you've got the logs into your SIM, you've written alerts on those logs. You're like, this is great, I have a ton of insight, I'm able to write alerts, keeping the teams active, finding bad, having a good time. Now you want to start reasoning about deploying OS query to production. You've only been deploying it to humans' desktops, now you want to deploy it to servers. What are some of the things you have to reason about? And, so this screenshot here, you're not supposed to be able to see what's on the screen here, but basically Launcher is this tool that we wrote at Collide that is a wrapper around executing OS query and connecting it to a TLS server, which is this very consistent way of a lot of people, I'd say 80% of people that deploy OS query in this way. And in order to do this with raw OS query, it requires something like 22 CLI options. It's ridiculous. There's just it's a very configurable process, and there's a ton of options. So on the right is OS query d -- help. And those are all the options. And on the left is launcher -- help. So hopefully you're using launcher at this point, and there's a lot less to reason about. But when you start deploying to production, it's kind of worth running OS query d -- help and just getting an understanding of what the options are that are available to you to tune this production deployment. So some of the important options that you should probably keep in mind are you can optimize the way that OS query schedules queries. And that is, if you do grep schedule, you'll see some of those options. You can also configure event-based monitoring. So I haven't really talked about event-based monitoring in OS query. I have talked about it in other talks. If that's interesting to you, I can send you some links. But basically, you might think okay, let's say you're running this query select star from USB devices. You run it every 60 seconds, and that'll tell you how the results set of the USB devices that are plugged into a host change. But what if you're running that every 60 seconds and someone plugs in a USB device, double clicks it, runs some malware, and then takes it out, and that happens in between two executions of the query, you'll miss it. But that's not necessarily the case, because there is an event-based subsystem of OS query that allows that will, in the case of USB devices, it'll subscribe to libudev, which is, the operating system exposes a variety of event-based APIs, whether it's for the file system, devices, processes that are executed, and OS query has a subsystem that ties into that gives you the kind of polling user experience that is easier to cognitively reason about, while still kind of buffering events for you to not be lossy. So if you want to enable and configure various aspects of that subsystem, the options are there. There's also the watchdog, which I'll talk about more in a few minutes when I talk about safety features in OS query, which becomes pretty important in production. But there are a lot of options there. And OS query also has a really nice extension ecosystem. So if you want to write your own capabilities, write your own internal tables that instrument perhaps an internal service, maybe you want to bundle that up as your own private extension. And you can configure how you load and run extensions there. So just things to there are a lot of options in OS query. Those are some important ones when you come to this junction. So packaging software in production is sometimes unfortunate, depending on where you work. So I used to work at Facebook, packaging, Facebook runs CentOS on all of production Linux hosts, and there is an internal packaging infrastructure that you had to buy into to deploy software to production. So, take the time, get familiar with how your organization packages OS query, or packages things and distributes them, and you're going to have to become pretty good friends with your organization's production ops people throughout this process. So make sure that you're packaging things how they would like you to be packaging things, or else you're going to have a hard time distributing things to all of your infrastructure. And the other recommendation that I will give you with regards to instrumenting production hosts is start reasoning about behavioral analytics. OS query allows you to kind of use this concept of labels to say if a host is returning results to this query, then group it as one of these hosts. So you might say select star from processes where name equals MySQL D. This is the MySQL label. All hosts that are running MySQL are a part of MySQL, this MySQL label. So you no longer have to reason about, well, I know that all of the hosts that are running MySQL are in that subnet or are managed by this chef recipe or whatever. You can just say if a host is running MySQL, then I want to run the MySQL intrusion detection that I have. And that will work for both your production MySQL servers as well as that random developer who has a developer server in your production environment that just happen to run a poorly configured MySQL. So you start reasoning about the things you want to monitor more dynamically, and that works really well in production because it is off with significantly large production environments. They're often not very homogeneous. You don't have the ability to understand exactly what's running everywhere, unfortunately. The other thing that I'll implore you to reason about as you start to think about host intrusion detection in production is you likely have a production logging pipeline at where you work. And Collide uses GCP. We have GCP PubSub that we use for a lot of logging. You might use Kafka. Facebook had Scribe, which was an internal tool, which was awesome. You may have something, but the key is that you should endeavor to use it, in my opinion. So Yeah, the TLS plugin can still be used pretty effectively in this case. If you wanted to like send logs to a central aggregated TLS server and then have the like a log forwarder or what have you, like aggregating logs on the TLS server and then putting them into your production logging pipeline, that might be an effective way to solve this problem, but you should endeavor to use the production tools that you have. And this is actually one of the original motivations for the like extensibility in the plugin architecture of OS Query, because at Facebook we had really strong ability to deploy software and configure the file system, and we already had log forwarders in Corp on desktops, but in production we had Scribe. And like if we there was no way that we were going to be able to handle all of the load using anything other than Scribe, so it was really important to us to be, but like obviously Corp doesn't have Scribe, because that would be terrible. So it was really important to us to be able to like take advantage of production tools when we had to, because like at some point this turns into a data problem. So you should be able like to take advantage of your production data infrastructure. Okay, so those are some important things to keep in mind. Now you're like, okay, you've got it to a few dev servers, you've got it to like one very, like the payments cluster, what have you, and now you're like, this is great, I'm like also getting some useful Linux data out of this. I want to complete my production deployment, and I'll say that this is largely a configuration management problem, unfortunately. So I have some screenshots here of Puppet, Chef, and Ansible, and I also have a screenshot of GKE, which is GCP's Kubernetes engine, and that's just to kind of say like, production environments aren't necessarily servers anymore. Like in Kubernetes, you have this cluster that's running a workload, and like you have Kubernetes primitives now for deploying like a single workload to every node. And at Collide, we run absolutely everything in Kubernetes. So like these mechanisms that Kubernetes has for distributing workloads, that's how we do config management at Collide. We don't really use Chef, Puppet, or Ansible. So that's great, really fun. We have these like very locked down production nodes, and we use the Kubernetes primitives to distribute software. So that's really fun. Config management, like obviously when you reason about like what is 100% of production mean in your environment, it might not be clear, and it usually means like it's in the base image. It's in like the base run list if you use Chef, or it's like it just really depends on your organization and what 100% means. But it's not clear, and it's largely a asset management and configuration management problem. So ideally, like you can't reason about 100% of production until you like have solved asset management and configuration management in your organization. So like perhaps this is another time where you should like segue and reason about asset management and production. And the other thing to be really mindful of with regards to OS Query in production are safety features. So for example, at Facebook, we wanted to instrument 100% of production. And Facebook runs some important web services, including things like newsfeed, ad servers, stuff like that. And like newsfeed can't go down because we wanted to monitor the kernel modules that were loaded on production Linux. Like it's just unacceptable, right? So we added a lot of safety features to OS Query that are kind of similar to how we deploy new software to production. And some of those, for example, are OS Query has this multi-process model that's like somewhat opaque to the user, but basically you can set configurable limits. So you can say, I want to make like low, medium, or high, like how stringent the requirements are. And if OS Query starts using a lot of CPU or a lot of memory, the supervisor process will just kill the worker. And then it will start up again, and the worker processes are very stateless, so this often doesn't really like make an impactful difference in your instrumentation, but it's just kind of a nice feature to make sure that OS Query can't run away with your production server's performance. And also, like even on the desktop, this is useful because like people get really upset when their fans turn on, and it's your fault. So keep that in mind. And in addition, one thing that we kind of stole from Facebook production and added to OS Query is this idea of shards. So we So at Facebook, we would deploy software. Let's say we had something we wanted to package and distribute to production. We would say, okay, like first we deploy it to shard 1, and this means that's 1% of all production hosts. That's going well. You like slow roll your rollout. Now you deploy to shard 5. That's 5% of all hosts. Then you do 10. Then you do 20. Then you do 50. Then you do 75, and then you do 100. And similarly, when you add a new query to your OS query configuration, you're now executing code that has previously not been executing on that server. There is like, when you run a query select star from processes on in OS query, the query gets parsed, planned, and executed, and instead of like querying a static set of data that already exists, it will execute some C++ code that like interacts with operating system APIs to enumerate the processes. And this is an important distinction, because if you were not previously running select star from processes and then you started, now you're running new code that you have never ran on any host before, and it is probably a bad idea to go and just distribute that query to 100% of production, especially when you reason about things like the way that the processes table works in Linux is it enumerates /proc, and sometimes /proc is mounted via NFS or something, and that could cause some interesting issues. So we had the /proc iteration code audited by the kernel team at Facebook, and they seemed to be pretty happy with it, but they were also pretty worried about interacting with /proc in general. So hopefully that works out. And there's also a lot of kind of internal tables. So the OS query team at Facebook, we would often use OS query to monitor OS query. So we had this great logging pipeline, and we would say, okay, like of all the queries that OS queries executing, like how many CPU cycles did each one take, how often, what's the memory profile of each query that we're running, and we would create dashboards to observe how, all right, we've pushed this query out to shard 5, what's the memory profile of it before we go to shard 15, stuff like that. So OS query has a lot of features for you to kind of like get those resource utilization things, and that's cool. So next step, final step, mergers and acquisitions. So like you have instrumented 100% of your production Linux environment, integrated it into your logging pipeline, you're writing alerts, it's all good. Every computer that your company owns has OS query on it, and it's like connecting to your central management server, like you're feeling awesome. And but you like need to be prepared, because your company could buy another company if your company is some mega conglomerate, and you might have to instrument that environment. So I would largely say this comes down to like 3 points. The first point is have packages ready. So like when my last employer made an acquisition, that environment was all FreeBSD. We had no FreeBSD in production. We didn't even run on FreeBSD at the time, but we had to make it run on FreeBSD and package it in a way that those hosts would expect, so that we could instrument that new production environment that just became our production environment. So have these packages available, like know how to package for different distributions of Linux other than your own, and understand the kind of like limitations of how and where you can run OS query. The other recommendation I'll give for you is like get comfortable with running your OS query TLS server on the edge. You may want to like put it in your internal VPN if VPNs are like still a thing that you're doing. All the cool kids are beyond corporate now. But yeah, get comfortable with, don't be afraid to put your OS query server on the edge. Other production environments, when you do M&As, like might not be in your VPN or in your intranet. So in order to effectively instrument them, you'll have to put it on the edge anyway. And this is also useful for instrumenting the desktop environment, because like people go home and they get compromised more often than they get compromised when they're in the office. So that's important. And then the final aspect of M&As is categorizable environments. So like I said, labels allow you to group kind of MySQL hosts, or hosts that are running Apache, or hosts that are like bound to a TCP port or something. Like you can categorize all of these things. And if you want to start instrumenting like not only a desktop environment or a production environment, but many different environments, like get comfortable with using these primitives to articulate groups of hosts that you want to apply various instrumentation to, because based on internal data privacy laws, or the ops team's ability to accept risk on those hosts, you may want to like cordon off different instrumentation that you perform. So some like really quick takeaways from this, I would say scalable intrusion detection is a commodity capability, and stay away from vendors that are trying to sell you special sauce. So in my opinion, all the tools that I've talked to you about today are open source, and you can pick them up off the shelf and use them to do incredibly scalable, incredibly advanced operating system analytics. And especially in the endpoint industry, there's been a lot of vendors who are like, we have this capability to do something and nobody else has it. Thus you need to pay us for our product. And I just fundamentally disagree that security features should be something that you have to pay for. Anyone, regardless of how much they can pay or what their budget is, should be able to do this kind of instrumentation. They should be able to gain access to this data. And if you have the tolerance to deploy your own server and do a little ops work, you should be able to get at all the raw data. And maybe the user experience of the application isn't as great, but the fundamental capabilities should be commodity, democratized capabilities, which they are with OS queries. So keep that in mind, and I hope you value that too. And I would also say don't use the features you don't need when you don't need them. It's really easy with OS query to tack on a lot of extra features, and try to keep it simple. You've heard the acronym KISS, keep it simple, stupid. So try to do that. And start in the desktop, balance risk and reward, and a lot of people don't do that and may disagree with that, but that is my hot take on where you should start intrusion detection. So with that, I have 27 seconds. And so if there are one or two questions, I'll take them. Otherwise, I'll be around. Yes. Yeah, great question. So the question is, OS query seems to enable you to find bad, but what about remediation? How do you take action based on the bad that you found? And OS query's perspective on this is that's a exercise for the reader. OS query prides itself on being read-only, and that is a safety feature of OS query. So one of the things that is unacceptable in a lot of production environments is you want to deploy an agent, and your ops team is you want to deploy an agent that's just going to kill processes? What if your logic is wrong? It's just going to start killing everything. So it was always a design goal of OS query to not, you can't insert, you can only select. But in the extension ecosystem in OS query, you can write an OS query extension that can mutate system state, and you can do inserts and stuff in OS query extensions. So if that is something that you'd like to use the OS query platform to distribute, you can, but by default, OS query is read-only by design. So the question is, in the cloud, you can just blow away hosts that are exhibiting anomalous activity. How does that change intrusion detection and this landscape? And I would say that so we use Kubernetes a lot, for example, at Collide. And one thing that Kubernetes is really good at is allowing you to articulate what should be there, but it's not very good at allowing you to determine what is there that it shouldn't be there. So stuff like that, I think, is really, it's still really useful to be able to understand, hey, I wanted to bind to TCP ports on these workloads, but why are these workloads also binding to TCP ports? That's weird. So being able to understand the environments separately, I think, is useful. And then additionally, if you are in the business of all right, I've identified compromise in my solution, my incident response action is to just kill that workload and start a new one, or take that node out of production and put a new one in its place or something, then you need to be able to detect some anomaly in order to make that decision. And I think that is where intrusion detection fits in these very amorphous production environments. And I'll take one more, yeah. Yeah, so the question is, do you deploy OS query on networking hardware or anything other than production servers and desktops? And I guess the answer to that is, so OS query runs on 64-bit architectures right now, Linux, macOS, and FreeBSD. And for example, at Facebook, the networking equipment that we had was Linux. It was like Facebook open source switching. They were like Linux boxes that we did SDN on. And if that's the case, then you could perhaps run OS query to do intrusion detection on it. But if you have like Juniper or Cisco routers, then no, you're not going to be able to run OS query on it. But hopefully your attack surface is also somewhat limited because like it's not a real operating system. Well, that wasn't supposed to be a snide remark, but cool, thank you. And if you have any more questions about OS query or host intrusion detection, happy to answer them.